Yeah, good evening everyone. Good evening. Good evening everyone. Let's share the screen. Let me share the screen. I think this is the place where we stopped yesterday. Am I right? Check. This is the place where we stopped yesterday. I hope we can start now. I hope we can start now. Check once. Verify everyone. Little doubt also there. Please verify. Sir, audio video having issue. If you have any issue, let me know. I am adjusting something. If any issue, let me know. I request everyone. Any small doubt also, let me know. This is the place where we stopped yesterday. So I'm starting now. I'm starting now. This is the place. Right, let's go ahead. Today's date is, I think, 14. Today's date is 14. 14 is going on. Let me write 14, 8, 14, 8, 26. Careful everyone. 14, 8, 26. Right, now I'm starting. Wherever we stopped yesterday. I'm starting now. I'm starting today's class. It's the first problem. Can you see this? Yeah. Good evening. Good evening, Sai Kumar. Good evening. Good evening. Thanks. I hope you are following this. I hope you are following this. Yeah, so I'm giving the today's class first problem. So how many days it take to complete discrete mathematics? Sai, it is already there in the if at all fast required, right? It is already there in the recorded. You can go and check. It is already there in the recorded. Please go and check. If it is urgently required, it is already there in the recording. You can check one time. Thanks for asking. Right? Let's check the problem. One problem is that let me check once. Right? See, write down now. So the problem is, I'm writing example. Let G be an simple. Let G be an simple undirected. Let G be an simple undirected connected graph. Right, remember, let G be n simple undirected connected graph with n vertices. Okay, and 25 edges, such that each vertex of G has degree at least 3. Then the maximum possible value of n is let G be n simple undirected connected graph with n vertices, 25 edges, such that each vertex of G has degree at least 3. Then the maximum possible value of n is. Can you give the answer? You know all the basics. Simple, you know. Undirected also, you know. Connected graph also, you know. N vertices also, you know. 25 edges, such that each vertex of G has degree at least 3. Okay. N vertices. He said N vertices. 25 edges. Then the maximum possible value of N is at least 3. Degree is at least 3. Na? So N vertices. Let's try this. Let's try this. It's going to be very easy. Let's try this. And what happened here is N vertices, right? Let me write now. N vertices are there, okay. 25 edges are there, that is also okay. Degree of each person, degree of each vertex, right? Degree of each vertex is minimum 3. But you know very well, sigma I is equal to 1 to n, degree of Vi is equal to 2 into number of edges. So this is the formula which everyone know, which will goes to 2 into 25. Sum of degrees. I think n vertices na. Every person degrees minimum 3. Remember, every person degree is minimum 3. Minimum 3 na. So it is not equal. Minimum, if it is exactly 3 equal. Minimum na. So definitely sum of degrees if you see, listen everyone, sum of degrees if you see, right? If you take only 3, actually some people may be 3, some people may be 3, some people may be 4, some people may be 10, some people may be 3, right? Am I right or not? Then if it is going, then it is going to be equal, right? Then it is going to be equal, right? Let me check here. If this is the case, then it is going to be equal. I think again, just 1 minute. Yeah, just wait. Yeah, fine. So if you take actual one, some people are 3, some people are 4, some people may be 10, some people may be again 3, some and so on. If you do like this, then both are equal. Okay. But he said that at least 3, we don't know. Maybe there may be chance that all 3 also, we don't know. So these are like the n people are there like this, right? If I do this one, 3 into n, it should be less than or equal to 2 into 25. Am I right or not? Why this value is less than this? Why? Because even though some people are 4, I taken as 3. Even though some people are 10, I took 3. Right? That is the reason. Because of everywhere I took 3, 3, 3, it is a less than or equal to 25. So this will goes to 3n is less than or equal to 50. Then n is going to be less than or equal to 50 by 3. So 3 ones, I think 3, right? 3, 6, 18. 3, 6, 18, afterwards 2 there, right? Again 3, 6, 18, something like that. So n value less than or equal to 16.6. Either 16.6 or less, you cannot take more. But you know very well, number of vertices cannot be fraction. Number of vertices cannot be fraction, but I cannot take more than 16.6. So n will be 16. So n will be 16. So it's a very good problem. It's a very small twist is there. Please take care. If you felt at anywhere little confused also, let me know. Sum of degrees is 2 into E. But you don't know what are the degrees. You know very well, every vertex degree is either 3 or more. 3 or more. Let's take everywhere 3. Let's take everywhere 3. Then you will get less or maybe equal also. Because of at least 3, there may be a chance that 3 also possible. There may be a chance that 3 also possible. Am I right? Fine. Any doubt there? Let me know. Any doubt there? Let me know. So can I move to next problem? Can I move to next problem? Let G be an simple undirected connected graph with n vertices, 25 edges, such that each vertex of G has degree at least 3. Then the maximum possible value of n is like this. Like this. I hope you got it. I hope you got it. Right? Fine. Perfect. Let's move to next. Let's move to next. I think everyone got it. Do you have any doubt? Till now, do you have any doubt? Till now, anyone having any doubt? If you want urgently anyone, please see the recording. If you want to follow this, follow. If you want urgently, then you can go to the recording. Thanks, Sai, for asking. Let's go to next problem. Let's go to next story. Everyone observe. One small story going to happen now. It's a very interesting story. Listen, everyone. Listen, everyone. I think I done all the things which are needed. If anything is pending, let me check. Anything I feel difficult, I will try. Number of edges we done. This also we done. Just I'm checking if anything I can give. If anything I can give. Yeah, that is okay. That is okay. Number of faces, number of regions, number of edges. This is also okay. This is also okay. Yeah, perfect. Perfect. Now let's come to next story. Everyone listen. Everyone listen. See this? Careful. This is going to be some other story. This is going to be some other story. This is going to be some other story. Everyone have to listen. Reload. Okay, perfect. It's going to be very difficult also. It's going to be very difficult also. Listen, everyone. One nice story there. One nice story. See this. Binary tree. Careful. This is something related to binary tree. So if anyone having any doubt, let's see this. If anyone having any doubt, can you see this? It's a binary tree. So it is a root, careful. It is a root. When you say it is a root, from root to everywhere you can go. So one person is root, right? This is the root. Careful. There is some linking. That is the reason we are discussing this. Right? It is a part of the graph theory also. It is a part of the binary trees also. It is a part of the graph theory. It is a part of the binary tree. First of all, binary tree is a graph. It is a directed graph. First of all, binary tree is a graph. Directed graph. When you say it is a binary tree, so there should be a root. From the root, other people, there is a path. Right? So if it is a root, so these are the children's. Children's are nothing but out degree. Children's are nothing but out degree. So I will write here A, B, C, D, E, F. A, B, C, D, E, F. A, B, C, D, E, F. I think it's a binary tree. It's a binary tree A, B, C, D, E, F. Right? Root is A. Because from the A, everywhere you can go. So A is having two children, and children are nothing but out degree. Children are nothing but out degree. So A is having two children. B having 0. C having 2. D having 1. E don't have. F don't have. So if you observe clearly, E is having 2. E is having 2 children, means out degree 2. Next one is having 0, is having 1, is having 0, is having 0, like this. Binary tree, so like that all are there. I feel everyone is comfortable. Now in this binary tree, right? So root is A is having 2 children, B don't have because no out degree. C having 2, so degree is right. So I think number of children's, right? So C is having 2 children. D is having 1 child. E don't have, F don't have, right? Remember, let me write here. Degree is equal to, right? A degree 2. A degree, because of it is a, right, because of it is a, I think, what can I say, it is a directed graph, na? It's not degree, it's out degree, right? When you say A is having two children, when you say A is having two children, when you say two children's, na, right? So two out degree, that's the meaning. Two children's means, right, two out degree, please be careful. Two out degree. Now see this one, children's is equal to out degree, I'm writing children is out degree. Fine, that is the first thing. When you say binary tree, 0 child possible, 1 child possible, 2 child possible, 3 not possible. That is one more thing. When you say binary tree, 0 child possible, 1 possible, 2 possible, 3 not possible. Children are nothing but out degree. Right? Fine. That is okay. Now listen everyone. The person who is having 0 child, that is called leaf node. That is called leaf node. 0 child means leaf node. The person who is having 1 child or 2 child, those are called as internal node. Those are called as internal node or non-leaf. Internal nodes. Right? Which is also called as non-leaf or non-leaf. Non-leaf nodes. So please be careful. Right? This binary tree is having, binary tree means 0 child or 1 child or 2 child. Right? When you say 0 child, leaf node. When you say 1 or 2, non-leaf node or internal node, like this. Children are nothing but out degree. Children are nothing but out degree. I think everything is perfect. Everything is perfect. Now understand everyone. When you say leaf node, 0 child. When you say leaf node, 0 child, please be careful. When you say children, out degree. When you say child, out degree, please be careful everyone. Please be careful everyone. Everyone careful. Children means out degree. Leaf node means 0 child. Right? Everything is fine. Now I am going to say one important story. In this diagram, if you observe, leaf nodes how many? In this diagram, if you observe, leaf nodes how many? Internal nodes how many? Can you count? In this diagram, if you see the leaf nodes, in this diagram, if you see leaf nodes, I think B also, F also, E also. I think 3 people. Leaf nodes are 3. Internal nodes are how many? A, C, D. Internal nodes also 3. Check. Total 6 people. Leaf nodes plus internal nodes. Right? Leaf nodes plus internal nodes is equal to the total nodes. Leaf nodes plus internal nodes are going to be total nodes. Total nodes. Leaf nodes and internal nodes are going to be 3, 3. Total nodes are 6. I think no one having objection till now. Now I am going to say one important story. Everyone, can you listen? Can you listen, everyone? Leaf nodes are, right? Leaf nodes are 3 here. Internal nodes are also 3 here. Now see, one small line. This problem contains 2 internal nodes, 3 leaf nodes. Total nodes are 6. Can you see this one? Total nodes, careful. Total nodes is equal to, understand, total nodes we want 6. Now total nodes means what? Leaf nodes plus internal nodes, which we want as 6, is equal to, what you do is, careful, what you do is, leaf, right? Internal nodes means 1 child also, 2 child also. When you say internal nodes, 1 child also, 2 child also, can you help me now? Internal nodes, totally 3 there, okay. Out of them, 1 child how many, 2 child how many? Let me check. 1 child is, I think, 1, only this person. Internal nodes are 3, right? Out of them, 1 child is 1. Can you say 2 child how many? 2. So total nodes is equal to, see the answer, 1 child how many there? 1. Next one, 2 child how many there? 2. 1 child how many there? Please check. 2 child how many there? Right? Those many. Right? 1 into. So 1 child how many? 1 person. 2 child how many? 2 people. That is okay. Next one. plus 1 plus 1 plus 1, that may be root. So if you count total, 1 plus 4 plus 1, which became 6. So remember, this is the one formula. To find out total nodes, this is the formula. Total nodes ln plus in, right? Leaf nodes plus internal nodes is equal to simply, right? One child domini. So 1 into that. Two child domini, 2 into that. Right? So this indirectly, directly internal nodes. We are talking about internal node story. Internal node story indirectly, directly. So this one, if you count, internal nodes will come. Right? This plus 1, that one may be for root. So if you do like this one, you will get total nodes. Those people who are not getting, so right, you will see one more problem, you will get it. Right? Careful. One simple problem you check here. I'm thinking that people are little bit okay. Sir, I am confusion. Can you say this? You have confusion, I can understand. Say this. Right? If you observe clearly, right? Just I want to calculate total nodes. Check here. Total nodes I want to calculate. I am going to use the same formula again. Total nodes means leaf nodes plus internal nodes. Total nodes are going to be leaf nodes plus internal node. There is one more formula. We will do that also. Please check in this. Who are leaf nodes? Who are internal nodes? Zero child means leaf node. I think 1, 2, 3, 4, 5, 6. These are leaf nodes. 6. Leaf nodes are 6. Internal nodes how many? Let's check. Internal nodes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. Total is 18. Check. Total nodes are 18. Whether I will get using that formula 18 or not, you can verify. Now see the answer. Here leaf nodes, leave it. Leave the leaf nodes to the internal node. Let's go to internal nodes here. In the internal nodes, one child how many find out, two child how many find out. One child how many, two child how many. I'm calculating one child. Is one child? 1, 2, 3. One child only. 3 until now. 4, 5. 5, I think 6, 7, I think 7. One child is 7. Check properly. Two child how many? I think if you observe clearly, internal nodes are 12. Na? From the 12, remove 7. I think 5. Yeah, I will check also. Two children you want. I will check also. See the two child. I think two child. 1, 2, 3, 4, 5. That's it. 5. So internal nodes are totally 12. Out of them, 7 contain one child, right? I think 2 child contain 5 people. 2 child is 5. So now see the formula. 1 child 7 people plus 2 child 5 people plus 1. So if you do properly, this will going to be 7 plus 10 plus 1, which will goes to 17 plus 1, which will goes to 18. So please understand this. Please understand this. Right? I want to say indirectly, directly this formula. This one and this one. Right? Careful. 1 into 7. 2 into 7. If you count it, you will get the total internal nodes. What are those? These two things count. 7, 1 child, 5, 2 child. Total internal nodes are 12. Right? But if you want total nodes, 1 into 7, because 1 child is 7, 2 into 5, because 2 child is 5. If plus 1, if you do, total nodes you will get. If you don't do plus 1, root may not come. This formula, everyone try to get. It will be really useful. It will be really useful. Right? I'm thinking you got it. I'm thinking you got it. Now I will give one question. Please see. Now I will give one question which you can solve very easily. Let's write. Right? One example. a strict binary tree, a strict binary tree T, a strict binary tree T, which has zero child or two child. Everyone know a strict binary tree T, right, which has zero child or two child. Remember, normally binary tree means 0 or 1 or 2, but when we say strict binary tree, either zero child or two child. Be careful. Has a strict binary tree T which has zero child or two child, right, has 200 leaf nodes. Have 200 leaf nodes. Then find number of nodes. Then find number of nodes in T. A strict binary tree T which has zero child or two child have 200 leaf nodes. Then find number of nodes in T. This is the problem. For this purpose only I done this much work. Can you give answer for this? A strict binary tree T which has zero child or two child. Everyone know strict binary tree means this is the definition. Strict binary tree means this is the definition. Zero child or two child. Have 200 leaf nodes. Then find the number of nodes in T. Then find the number of nodes in T. Can you go ahead? Make it fast. A strict binary tree T which has zero child or two child have 200 leaf nodes. Then find the number of nodes, right? Then find the number of nodes in T. Means he is asking total nodes. He is asking total nodes. If possible, can you try? Remember, it is a strict binary tree. Yeah, I will try to give answer. I am trying to give answer. Please check here. Leaf nodes. Leaf nodes means zero child, na? Leaf node, 200 leaf nodes. Right? Leaf nodes are 200 leaf nodes. Try to understand. Then find the total number of nodes in T. Okay? Can you give answer? Or what way you want to follow this? What way you want to solve this? It is a strict binary tree. Be careful. It is a strict binary tree. Zero child. Remember, one child is not allowed. One child is not allowed. Remember, one child is not allowed. Be careful. One child not allowed. There is no one child. Either zero child or two child. So what is the answer? Leaf nodes are 200. Leaf nodes are 200. Zero child or two child. There is no one child. There is no one child. So all internal nodes contain two child only. All internal nodes contain two child only. Please try to understand. All internal nodes contain two childs only. Please try to understand. Right? So if you want, you can give the proof also. Now see, I am trying. See this one? Leaf nodes plus internal nodes. Right? Leaf nodes plus internal nodes means total nodes, no? See this one. Total nodes, carefully. Total nodes is equal to everyone now, right? Here I think internal nodes are having two child only. So 2 into internal nodes plus 1. This is the formula. Because 0 child, 0 into anything becomes 0 into anything becomes 0. So 0 no need to write. Sorry, 1 ಮಾಡಿದೀಯಲ್ಲ 1 not there, no need to write. 2 into internal node, because every internal node contain 2 child only. This is the reason. So then total nodes are leaf nodes plus internal nodes is equal to 2 into internal nodes plus 1. So I think your leaf nodes are already 200 plus internal nodes. Internal nodes you can send that side is equal to internal nodes plus 1. Finally, internal nodes are going to be 200 minus 1, which is going to be 199. Please check if you want. Make it fast. One simple formula will solve your answer. One simple formula will solve your problem. Please let me know. Sir, I have this issue. Sir, I have this issue. Please let me know. Am I done anything calculation wrong? Am I done any calculation wrong? Please verify. Is there any calculation wrong? Internal nodes, if you send that side, it will become 2 into internal nodes become 1 into internal node plus 1. Internal nodes is going to be, right, 200 minus 1, 199. I hope so. I hope so. If I am done anything wrong, let me know. Sir, you done something wrong, sir. Let me know. Right, 199. Internal nodes are 199. Total nodes, I think, is asking total nodes in the problem. Total nodes is asking. So total nodes are 200 plus 190, which will goes to 300. These are total nodes. Perfect. I hope people got it. One more problem I'm giving. Can you solve this problem also? Can you solve this problem also? Careful, careful everyone. Careful everyone. Same story. Same story. You can solve this problem also. Right? Let's check. Example. Let me try. Let me try. A ternary tree contain. Careful. A ternary tree contain. Ternary tree contain. I can say a ternary tree contain 50 leaf nodes. 50 leaf nodes and 5 nodes. 5 nodes with 1 child. Next one. 15 nodes with 2 child. 30 nodes with 3 child. Some random number I am giving. A ternary tree contain 50 leaf nodes. Some number is there. 5 nodes with 1 child, 15 nodes with 2 child, 30 nodes with 3 child. Right? 50 leaf nodes. Means 0 child is 50. Is it really possible or not? I don't know. We'll check once. Then find total nodes how many. Then find total nodes how many. As usual. Same story. As usual, same story I am doing. So total nodes. See this one? Leaf nodes plus internal nodes is equal to. So leaf nodes how many? Leaf nodes how many? Right? Is it really correct or not? You can check one time. Leaf nodes how many? I think 5. 50. Internal nodes how many? 5. Right? 5 nodes are going to be 1 child. 15 nodes are going to be 2 child. 30 nodes are going to be 3 child. These all are internal nodes. These all are internal nodes. Let's check one. 5 plus 15, 20, 20 plus 30, which is going to be 50 again. It looks like 100. Let's try. Is it working or not? 5 into 1, 1 child. 15 into 2, 2 child. 30 into 3, 3 child. Right? Please verify properly. Please verify properly. So which will goes to 30 into 3, right? 30 people are having 3 child, na? 30 people are having 3 child. So you will get to know clearly. 30 people are having 3 child. So 30 into 3, 90. 90 plus, so 15 to 30, 35. 90, so 90 plus 35, which is going to be 125. This is 125. Check properly. So it should also be 125. So it should be 75. Otherwise, it is not possible. If you want, you can try the diagram also. It is not possible. I given random numbers. Right? It's not possible. If you want, you can check. Try to draw the tree. A ternary tree contains 75 leaf nodes. Because I written randomly, random things cannot work, right? A ternary tree contains 75 leaf nodes, 5 nodes with 1 child, 15 nodes with 2 child, 30 nodes with 3 child, then find total nodes. So total nodes are, I think you can count and you can easily say that. But is it really possible or not? I verified. So this is. So I changed accordingly. Right? Fine. But remember, it is a ternary tree. It is not strict ternary tree. It is not strict ternary tree. Right? Try to understand. Right? Now, I think just give me 1 or 2 minutes. I will resolve this issue. Many people are asking, why PPT? Why EPT? Why should I join EPT? Not PPT, EPT. Right? Many students are asking, what is the purpose of, if I join EPT, what I will get? You will get the English classes only, because as an engineering student, as a tech student, you need English, right? So if you study Hindi, Telugu, Tamil, right? So you can study other things, tech things, everything is available in English only, right? All tech things, whatever you read, tech things, normally in English. Interviews also English, jobs also English. So I request everyone, even though difficult, please follow English only, right? So all classes are in English only, live also there, record also there, daily quizzes are there, right? So if you can verify, go to the exam prep 2 website, you will find out daily quizzes, right? Doubt solving is there, right? Gate PYQs and the verified questions are there, guidance, right? Mentorship is there every Saturday, Sunday, and the strategic plans also available every day. Every weekend we will give the targets also. Every weekend we will give target. Tomorrow we will give to every student target. Missing people, Sunday also we will give target of each student. Each student we will give target every weekend. Every weekend we will give. Right? Next. These are our students who topped the GATE examination. I hope you will also top the next year GATE exam. Next, right? So last year for 200 students we given the free education. This year I want to give for 1,000 students we want to give free education. 1,000 people we want to give free education. The only thing is you should be in the class top 5. If you are there in the class top 5, please send the mail to info@exampreptool.com. Please send to this mail ID exampreptool.com. We will give the free admission. The only thing is you have to pay platform fees of 2,000. Right? Almost free. Right? Just you have to pay platform fees 2,000. So with 1,000 rupees only. 1,000 times, I'm repeating once again. With 2,000 rupees only, you will get everything. Whether you are preparing for a placement or GATE, right? We will provide everything to you. Right? The only thing is you should be top 5. I strongly believe financial things cannot stop any student's life. So I face a lot of difficulty when I'm a student. I thought similar things are facing by the students. I am able to see also. So I want to help as many students as possible. So if you are preparing to GATE or placements, right? So if you are in the top 5, you can utilize this wonderful opportunity. Right? Now, next one. So in the EPT, live classes also there, recorded classes also there. Now live classes, 3 batches are going on. Live classes, 3 batches are going on, right? One batch for, right, discrete mathematics, whatever is going on now. One more batch, RIC course is going on, where aptitude subject for all these branches, GATE CSE, GATE DA, and GATE Triple E, CSE, DA, ECE, and Triple E for all these 4 branches. For all these 4 branches, right, RIC course is going on, where RIC course contain 3,500 quality questions with video solution. Expected to be most of the questions will come in GATE examination from this RIC course. Last year, approximately 50 plus questions came from RIC. So, if you want to be a topper, I strongly recommend this course. You want to be a topper, I strongly recommend this course. Morning data structure going on for GATE CSE, DA, and placements. Right, morning 6 o'clock data structure going on. Right, evening, right, 7:30 discrete mathematics is going on. Right, so the 8:30 p.m. evening in EPT portal. Right, RIC aptitude is going on. RIC is going on for all these branches. Current subject is aptitude. And the most important thing is tomorrow 6 p.m. Tomorrow 6 p.m. Tomorrow 6 p.m. there is a mock test for all the gate branches. Tomorrow 6 p.m. there is a all India level mock test. I request everyone please attend. I request everyone please attend. Please check yourself. In the mathematics, what is your position? Please verify. Now come here. Now come here now. So for the CSE student, C programming is freely available on EPT also, YouTube also. Right? YouTube channel also and EPT also. It is a freely available. Please go and check. Right? For a DA people, Python is freely available. For the CSE people, right? Discrete mathematics also freely available. Please utilize. I request everyone, please utilize this. Now come here. Come here now. So if you are seriously preparing GATE examination, serious aspirant, you can go to the premium courses. You will get all benefits. If you take this course, there may be a chance that you will get 100 marks out of 100, because everything is available. Everything is available in the premium courses. In the GATE affordable courses, some things you will miss. Some small things you may miss. RIC course you don't get. Most of the questions will come in the GATE examination from RIC course. You may miss RIC. Right? And one more, most of the questions will come in the GATE examination from RIC and test series. You may miss practice. Affordable courses, right? You may miss these 2 things. Remaining all, I think, mark test also possible. Remaining all possible. So if at all financial problem, you can go here. Right? It's a, right? If at all financial problem is not there, you can go here. So you will get 100 out of 100 marks here. Affordable, you may get 95. You may get 95 marks out of 100. Small, right? It's few things you will miss out. In the free resources, some things we given free, and also maybe you will get 50 marks out of 100. You may get. Right, so because some few things only free, that is the reason. So you can utilize whatever you want depending upon your ability. I strongly believe education should come as minimum cost as possible. EPT courses, if you see, very less cost. 2 years also, 2 years course also you may get within 15,000. 1 year course, you please verify as minimum cost as possible. I given affordable, everything affordable. Right? With education, you cannot do business. Education is not for the business. It is for growing the students, helping students. Right? So if you money problem not there, go to the premium courses, because you will get 100 out of 100 mark. If you study properly, every possibility we get. Affordable, you may get 95 marks out of 100. Right? This is also best course if you have a financial problem. Few things you will miss out. Free resources, right? So I think, right, free resources, few things only there. That is the reason you may get less marks. But if money problem, I think you can go here, right? If at all okay, then you can go here. So no problem at all, you can. But all are affordable. You can check once. Test series also, if you want, you can take mentorship every weekend. We will give targets.
right? So GATE plus top PSUs, GATE plus placements, right? GATE plus right, UGC net. These all courses are there, right? You can take whatever you like. EPT for the students, you can take whatever you want. So many free resources are available on the EPT website. Please go and visit. Assignments are there, toppers notes there, previous year questions there, doubt solving is there, mentorship also there. You can utilize. And these are the right. These are the people who used the EPT placement course. They got big companies, big companies. They got. I wish you will also get. So DSA course you can go, DSA plus system design you can take, DSA practice course you can take, right, interview courses you can take, language courses you can take, development courses you can take, whatever you want you feel. Just visit. Please explore the EPT web. These are free on the EPT website. Check. This code you can apply. 70% is offer going on. Within maybe tomorrow, day after tomorrow, that will close. Tomorrow, day after tomorrow, it will be closed. So please utilize it. Not 60%, 70%. Yeah, thanks for listening. Let me go to another problem. Let me go to another problem. It will give more clarity. Let me give another problem. Please careful everyone. Everyone careful. So whatever formula I said till now, please use that. Whatever formula I said till now, please use it. Now I am going one more problem. With this, we can end it. Let's see. Consider a binary tree. Consider a binary tree. Okay. Consider a binary tree which contain 20 nodes with one child. Okay. 30 nodes. 30 nodes with two child. 30 nodes with two child. Okay, then total number of, then find total number of nodes and leaf nodes also, total number of nodes also, and leaf nodes also, and leaf nodes. Same model you have to follow. For this problem purpose, I done. For this problem purpose, I done. Consider a binary tree which contains 20 nodes with one child, 30 nodes with two child. Then find total number of nodes and leaf nodes. That's what is asking. I think binary tree contain, if you observe clearly, binary tree contain 0 child also possible, 1 child also possible, 2 child also possible, 20 nodes with 1 child, 30 nodes with 2 child. Right? Be careful. Now I'm starting. Let's apply same story. I'm writing now. Total nodes is equal to, we'll do that, which is internally leaf nodes plus internal nodes. Total nodes are going to be leaf nodes plus internal nodes. That is the story. How many internal nodes are given? I think a binary tree internal node means I think one child or two child. This. Check properly. How many nodes? I think 20 plus 30, 50. But leaf nodes, we don't know. We have to calculate. Let's go here. Leaf nodes plus 50 is equal to, let's check here. 20 into 1 child, 30 into 2 child plus 1. Right? Which will goes to 20 plus 2, 3, 60. And 60 plus 20, 80. I think 81. Check once. 30 into 2, 60 plus 20. 80 plus 1, 81, right? Now next one, leaf nodes is going to be 81 minus 50, which is going to be 31. So total nodes here are going to be, total nodes are, right? I think 31 plus 50, 81, already there, directly there, already. So total nodes are 81, leaf nodes are 31, please take care. Yeah, exactly, exactly. Thank you, Aditya, thank you. So it's a nice problem. For this problem only, I said before some discussion done. If anyone don't know this formula purpose, I done a lot of discussion. Please verify. Remember, the story will come into the picture when you say one children's terminology, tree terminology. Try to understand tree terminology. Try to understand. Now I will give one more problem. It's very simple. I think everyone can do it. It's very simple. Everyone can do it. Let's see. Find find number of vertices. Find number of vertices in an undirected in an undirected in an undirected connected graph. Yeah, undirected connected graph. Right, find number of vertices in an undirected connected simple graph. Connected simple graph with 27 edges, 6 vertices of degree 3, sorry, of degree 2, 3 vertices of degree 4, and remaining vertices of degree 3. So I will read the problem once again. Find the number of vertices in an undirected graph, in an undirected simple connected graph with 27 edges, 6 vertices of degree 2, 3 vertices of degree 4, and remaining vertices of degree 3. It's a very simple problem. It's a very simple problem. Can you go ahead? It's a very simple problem. Can you go ahead? Find number of vertices in an undirected connected graph with undirected connected simple graph with 27 edges, 6 vertices of degree 2. Remember, it is a degree 2, 3 vertices of degree 4. Remember, this one and binary tree no relation. Don't link it. Don't link it. This one and binary tree no relation. There is no children's here. There is no binary tree here. So don't link it. Number of edges are given. So assume number of, because you want number of vertices, assume number of vertices is equal to n. Assume that. Now start. 6 vertices with degree 2 plus 3 vertices with degree 4 plus remaining, I think 6 vertices, 3 vertices, I think 6 plus 3, 9 vertices over. Remaining is n minus 9. N minus 9 vertices with degree 3. I think this is going to be sum of degrees. This is going to be sum of degrees is equal to 2 into E, where number of edges. It is a 12 plus 6 to 12, 3 4 12, n minus 9 into 3 is equal to 2 into 27, 54. Right, so I think it is a 24 plus 3n minus 3 9s 27 is equal to 54. From the 24, if you remove 27, I think it's minus 3. 3n is equal to 54 plus 3, which is 57. So overall, n is equal to 57 by 3, which is going to be 19. Number of vertices are 19. Can you verify? Find number of vertices in an undirected connected simple graph with 27 edges, 6 vertices of degree 2, 3 vertices of degree 4, and remaining vertices of degree 3. Do you have any objection? Let me know if you have any objection. Bro, if you have any objection, let me know. Yeah, I think this also done. Don't link this one and binary tree. Please don't link. I request everyone, please don't link. This one and binary tree, please don't link. I expect everyone. Please have some decency. Don't link wherever you want. Don't link wherever you want, like people used to link. Like people used to link. Right? So Indian Prime Minister and right, one more is what? I don't know. So I don't want to enter into unnecessary controversy. Don't link unnecessary stuff. People are linking Prime Minister itself, they are linking. Don't link unnecessarily. People linking Prime Ministers also. So don't link this undirected graph and binary tree. Please don't link. There is no children terminology. Right? Fine. I think you got. Now I want to say one important story here. See, next story is based on this. Please be careful. Next story is based on this. Right? I think before going to that, one small question is there. I will do that also. Let's see. Let G be an undirected. Let G be an. Let G be a. Let G be a simple. Right? Simple. Right? Let G be a simple connected planar graph with 10 vertices, 15 edges. Remember, it is a planar graph, connected planar graph. Be careful and simple also. With 10 vertices, 15 edges, then find number of bounded regions. So only for this line, bounded regions purpose, I am given this problem. Only bounded regions purpose I given this problem. Yeah, go ahead. Let G be a simple connected planar graph with 10 vertices, 15 edges, then find the number of bounded regions. First find regions, we'll talk about bounded regions. Right? Now I'm writing. Because of the simple connected planar graph, so formula is E plus R is equal to E plus 2. There's a formula. Vertices given. Regions we don't know. Number of edges also given, plus 2. So number of regions is equal to, so 15 plus 2 minus 10, which is going to be, I think it's a 17 minus 10, which is 7. 7 regions are there. Now I want to say one important thing. Everyone can see this. Everyone can see this. Everyone can see this. Make it fast, everyone can see this. It is a planar graph because no edge crossing. It is a planar graph. Every planar graph will divide the plane into regions. It is a one region, it is a one more region, it's a one more region, 3 regions, but outside is one more region, 4 regions. Every planar graph will divide the plane into regions. Out of those region, one region is outside region. Right? What is asking, then find number of bounded regions. So I think for the outside region, no boundary. See, outside region, no boundary. You can go here also, here also, here also, here also. Right? Outside region, no boundary. He's saying that bounded regions how many? Except one person. All are bounded regions. So these are total regions out of them. Right? So 6 is going to be bounded regions. 1 is going to be unbounded region because it is outside. Perfect. Okay, I hope you got it. Just I want to clarify this point also. I want to clarify this point also. Okay, let's see one small story. Let's see everyone one small story. One small story there. I will cover that also. Can you see this one? A, B, C, D, E, F. Understand everyone. A, B, C, D, E, F. We are talking about simple graphs only. I am saying from starting onwards. We are talking about simple graphs only. Please be careful. Every time we will talk simple graphs only, not multigraph. No need to write also. Be careful. Now, simple graphs only we are talking, no need to say again and again. Observe this diagram. Totally 6 vertices. Observe this diagram. Number of vertices with odd degree till now. No one is there, right? No one means 0. Number of vertices with odd degree. No one is there. So 0 vertices, careful. 0 vertices with odd degree till now. Number of vertices with odd degree. 0 vertices with odd degree. See the diagram and talk. No one is there with odd degree. So 0 vertices with odd degree. Okay, fine. Now say this one. One edge I written. I think C also degree 1, B also degree 1. Now if you observe 2 vertices with odd degree, check. Now what I will do is, I will add one more edge. See this. I will add one more edge. If you observe clearly, see previously 1 degree, now it became 2 degree. It's not odd degree, but A became odd degree. B already odd degree. I think 2 vertices still with odd degree. That is also fine. Right now, let me add one more. If you observe clearly, A odd degree 1, B odd degree 1, D also 1, E also 1. 4 vertices with odd degree. Check if you want. Now I will write randomly one line I will write like this. Randomly I will write one line like this. If you observe clearly, A previously odd degree, now it became even. Previously F, if you see, even degree because 0, now it became odd degree. So one odd degree person became even, one more even degree person became odd. If you observe clearly, B odd degree, E odd degree, F odd degree, D also. I think still 4 vertices with odd degree. If you want, you can do whatever you like. Whatever you want, you can do. Right? Note, this is very important point. What is the note? In simple graph, we are talking about simple graph. In simple graph, in any simple graph, in any simple graph, in any simple graph, number of vertices with odd degree. In any simple graph, number of vertices with odd degree is always even. Is always even. Be careful. It's a very powerful statement. In any simple graph, number of vertices with odd degree is always even. In any simple graph, number of vertices with odd degree is always even. Be careful. Be careful. This is a very powerful statement. 0 vertices with odd degree, 2 vertices with odd degree. You check all. All are even numbers only. You check all the people even. I tried my level best. Can I get odd? It's not possible. Number of vertices with odd degree. Right? Always even. In any simple graph, number of vertices with odd degree is always even. And one more. 6 vertices are there. Careful. 6 vertices are there. Right? Maximum degree possible for anyone. 5. So E may be adjacent to all people. E may be adjacent to all people. So 1, 2, 3, 4, 5. So you know this very well. In n vertex simple graph, in n vertex simple graph, maximum degree of any vertex, max degree of any vertex degree is n minus 1. That point also everyone. Number of vertices with odd degree is always even. Right, next one. In any, right, in n vertex simple graph, maximum degree of any vertex is n minus 1. I hope you are okay. This point, these 2 points are very, very important. Based on that, there is a one problem. Let's see the time. Yeah, fine. I think so. Fine. I think it's fine. In the next class, in the tomorrow's class, we will see the remaining thing. In tomorrow's class, we will see the remaining thing. Yeah. Thank you so much. See you in the next class. Thanks. Thanks, everyone. Thank you. Thanks, everyone.